last one. So given the same function we were just working with in example 3a, interpret the value as a difference of areas. Interpret the integral, okay, as a difference of areas. So recall earlier in the lesson, we had a formula for that if we're asked for a definite integral from a to b, it is the same as taking the area above and subtracting the area below, okay? So area above minus the area below. And that is to give me the answer to the integral. Okay, really important that we understand the difference between integral and area. What is it asking me to calculate? So this is going kind of back to our chapter 10. And so let's draw a picture of x cubed. All right, let's see, what does x cubed look like? Something like this. And we're going to go from -1 to 2. And so we can see that there are two regions. There's a region below, and there is a region above the x-axis. Okay, and so this is saying the region above subtract the region below will give me the answer to the integral, not to the area. If I wanted the area, of course, I would just calculate those and add them together. Okay, so I need to calculate each of these regions. Okay, so let's call this A1 since that's the one above. And so A1 goes from, well, where are we intersecting the x-axis here? We're doing it at 0. Okay, so this A1 is going from 0 to 2. That's that region. And my function is x cubed. In terms of x, I'm going to calculate this. So I'm going to just take the antiderivative. I'm not going to do sigma notation on these ones, okay? Okay, so the antiderivative of x cubed is 1/4 x to the 4th, evaluated from 0 to 2. Okay, so the area of region 1 will be 1/4 would be better to start with. 1/4 2 to the power of 4 minus 1/4 times 0 to the power of 4, which is going to be 2 to the power of 4 is 16. 16 on 4 is 4, because anything times 0 is just 0. Okay, so that's the first region. That's the region, the area above. And then since this is area, I'm going to actually put units squared. So it's 4 units squared above the x-axis. Okay, region 2 is below. Okay, I want red. Come on, there we go. Okay, so A2, this is the one that's below. Okay, so it starts at -1 and goes to 0. And the antiderivative is still 1/4 x to the 4th, but this time my boundary is -1 to 0. Okay, so this is going to be 1/4 times 0 to the power of 4 minus 1/4 times -1 to the power of 4. So this is 0 minus 1/4. So that's equal to a -1/4, right? Okay, but if it's representing area, we know area has to be positive. So this is where we would actually then take the absolute region of that, absolute value of that, and the area of region 2 is actually 1/4 units squared. And then taking that into account with the formula that says, so we're going from -1 to 2 of x cubed dx is equal to a1 minus a2. Area 1 was the area above, which we calculated as 4, and area 2 is the one we just calculated as 1/4, and this is to give me the answer to the integral. Okay, so 16 on 4 minus 1/4 gives me the answer of 15 on 4. It's not going to be units squared this time because this is the answer to the integral, which was the same as we got with our sigma notation. Okay, answer to the integral. Now, if I had said, what is the area? Okay, what is the area? Then we would have just added those together. Okay, 16 on 4 plus 1/4 would be 17 on 4. That wasn't the question. The question was to calculate the integral as a difference of areas. Okay, so this is the answer to the integral is 15 on 4 because we have a little tiny piece that's shaded below the x-axis. Okay? All right, so that's the end of this lesson. Crazy but true. This is just that tail end piece of example 2 at the bottom here. And so I'll see you back for 11.2. Have fun with this.